Now, for the U.S. audience, which it's really not that much you can do with 35 degrees Celsius, which I guess comes out to be about 85 Fahrenheit temperatures. It's not very much you can do with that in the U.S. But in Sweden, actually, the majority of our country is connected to the district heating grid, which so that's one big geographic benefit of being in Sweden. But then there's there's multiple megatrends which are transpiring, just taking place at the moment. We have the ever increasing workload densities of the racks, which is also in turn generating higher and higher out temperatures. So we have a verbal client commitment from a European cloud challenger that wants to put their operations, their IT load in our facility. And basically their out temperatures will be 60 degrees Celsius, which is way higher than 35. And why that's important is that's part of another megatrend, which is actually the efficiency gains of heat pumps. Basically, when we talk about heat pumps or refrigerators, you talk about COP, coefficient of performance, and which that basically means is how much energy do I need to put in for every degree of higher temperatures it generates. And it's not linear. So the higher the temperature it receives, the easier it is for it to get the out temperature up to the 75 to 95 degrees Celsius, which you need to run a proper district heating grid. So the economics have become much better recently. And then on top of it, modern district heating grids are actually run at much lower temperatures. And all of a sudden now you're getting pretty close to not needing heat pumps. So you can literally take the servers, the on-chip servers, and on-chip cooling servers, and connect them directly to the district heating grid. And you don't need to use any more energy to do the heat transfer. And that's when it starts getting really interesting from an economic perspective. So there's a couple of other megatrends playing out. I guess the big one in Sweden is that the politicians, which I'm sure will start playing out in the US as well, because Sweden got burned pretty badly by US hyperscale establishments. Maybe because they wanted to hear it, maybe because people really thought it would happen. But there was lots of promises when the US hyperscalers came to Sweden that there would be lots of job creation, 6 to 1, one job in the data center, 6 outside the data center. Now, that hasn't really happened, and there really hasn't been any development of an ecosystem around the data center to speak of. So the allocators of power in Sweden are quite reluctant to give more power to data centers because they see very little societal benefit. They would prefer to keep that power in place. So if there's a new factory establishment generating 2,000 jobs instead of 20 jobs, they'll make sure they can find that. And that's kind of, in essence, what we're trying to do is we're trying to see and create a data center platform which works in harmony with the green transition. I.e., we see Sweden as having 290 municipalities and 240 have district heating grids. In an ideal scenario, you would have a bespoke data center being the energy hub, the data hub, and the heat hub of this community. And that all of a sudden changes the narrative, and you can start creating the highest possible societal outcome per megawatt. And that will give you an unparalleled access to power in an environment when you need power.